The Chapter 11 homework. There are only 5 problems, but they're pretty detailed. Ooh, that's kind of zoomed in a lot. I do need to correct one of them, though. So this is 41. We went over this in class, talked about it quite a bit on Friday. This one, I'm going to alter, saying that for F, the dV is negative 10 meters per second, but the final V 4 seconds is plus 10 meters per second. So, kind of need to mention that because that came up in class. So these ones I don't think we need to talk too much about. Pretty cool how all the momentum and impulse stuff work with the energy stuff. Some subtleties here in terms of concave up, concave down. The fact that this is spiky, I didn't draw very well. For number 42, basically you've got negative work done by gravity if something's being lifted up, since gravity is acting downward and the force and the motion is upward. And then positive work done by tension. You should have a total change of energy that's positive since it's accelerating upward. Otherwise, you would just have, if you're moving upward at a constant speed, you'd have a conversion of work going into gravitational potential energy. So the change in kinetic energy is 10,000 joules. That means this thing actually ends up at 4.47 meters per second squared. You could also do that with kinematics, by the way. Figure that out. This one was pretty neat. We went over this in my mod 15 to 18 class, but not the 23 to 26. So this is coming down the hill, and the force of the air or the wind is 200 newtons, but it's coming horizontal. Only a component of that is actually acting against the person's motion. So I figured out this distance down the hill was 146 meters, and that the equivalent of 188 newtons is acting against it. That's the horizontal component of the wind. So 188 newtons times 146 meters tells me the negative work done by the wind. That offsets most of the positive work done by the Earth, or the decrease in gravitational potential energy. And what's left over would cause the person to be moving at 15.7 meters per second. 50 is kind of neat. I like the way that it looked. The sticky spot was kind of weird. That did slow it down enough where it would just not reach the truck. So, a little unfortunate that a sticky spot was as sticky as it was. It says assume for number 57, you've got a spring up here 10 meters above a reference location. This person goes down, and you want to find out how far up the slope they go. So I did not assume that that was up in terms of height off the ground. I assumed its distance along the slope. If you did assume it was height off the ground, then you'd get something about half as much since it was a 30-degree angle. So basically, the initial energy is gravitational potential and elastic potential energy up here. That's a total of around 19,800 joules that are available. That then converts back to gravitational potential, but also into work done, thermal energy basically, because the work is done by friction against the object. So put all those in terms of variables. And honestly, this would be the way that you'd probably see it on the AP exam. So this problem gave you numbers though, so it comes out to 32.1 meters up the hill. Hopefully those help out with work energy conversions. I think that's kind of a big deal. We do need to do a little more with some of the calculus with it as time goes on, recognizing that work is Fx dx, so that's the integral of force versus displacement graph, and impulse is F times dt, which is force applied for a certain amount of time. All right, that should do it.